or one of the x-intercepts. Okay, that's where this comes in. This is also straight out of your book. I know there's some confusion always as to what does 0 mean, what does x-intercept mean, what does, what do all these things mean? Basically, they're all the same. Pretty close to the same anyways. Okay, a real number, c, is a 0 of p. So let's give an actual example of a polynomial here. Let's say we have the polynomial x squared plus 3x minus 10. Okay. And let's see if we can find a 0 for that polynomial. To find zeros, we set it equal to 0 and try to solve it. Are there factors of negative 10 that adds equals 3, x plus 5, and x minus 2? We set each of those equal to 0. Okay, so this is the process we normally go through to find zeros of a polynomial. We get x is negative 5 and x is 2. So negative 5 and 2 are zeros of the polynomial x squared plus 3x minus 10. So let's just pick one of them. Let's say negative 5. So negative 5 is a 0 for the polynomial x squared plus 3x minus 10. Also, if we put f of negative 5, if we plugged negative 5 in for x, we would get 0. X equals c is a solution to plug in equal to 0. We found that there. If we put 0 equals x squared plus 3x minus 10 and solve it, x, or negative 5, will be one of the answers, and it was. X minus c is a factor, so x minus negative 5 was our c, which becomes x plus 5. Was that a factor? Yes, it was. And the point c0, the point negative 5, 0, is an x-intercept for the graph. So all of those things just from solving for negative 5. Okay, so those all, I know it can be confusing, all this terminology, but basically if you put a number in and get 0, it's a factor. X minus that number is a factor of the polynomial. It's an x-intercept. It's the solution when you set it equal to 0. If you plug it in, you will get 0, and it's called a 0. Okay. What do we use the factor theorem for? We use it to break down our polynomial to solve it more than we did in the originally. Okay. So usually what books will do is they'll ask questions like this. Find the rest of the zeros, or the remaining zeros, for this polynomial. Okay, right here, x to the third plus 4x squared minus 5. We can't factor that to find the zeros right now because it's got an x cubed and an x squared. We don't know how to factor those. But they're saying it will give you a hint. We'll tell you one of the zeros is 1. Okay? Well, if it's a 0 or a factor, we learned from the factor theorem that when we do synthetic division, we should get 0 at the end. So let's check that. What this is going to do is help us break it down a little. So we put a 1 there. Our polynomial 1, when we're doing synthetic division 4, we put a 0 for our x and a negative 5. Okay? Drop it down, multiply. Should be getting a pro at this by now, hopefully. Add 5. Oh, and notice my remainder is 0. That's a good sign. That means I did it correctly. Okay? So what that does is breaks it down a little, because remember, it was a third. I divided by basically x minus 1, which breaks it down to an x squared plus 5x plus 5 is what I have left. So far, factoring, my function is the same as x minus 1 times x squared plus 5x plus 5. I know that this portion gives me the 0 of 1, right? I could do that, but I already know they told me x1 was a 0. That's how I did this. Now I can use what's left. Once you're down to an x term, you're good to go. Because we know how to, or a squared term, we know how to solve squared terms. We set them equal to 0, and we either factor them or we plug them into the quadratic formula. This one does not factor, so we are forced to use the quadratic formula to find the other solutions. So we go ahead and we do negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. We simplify that. We get 25 minus 20 inside there, or 5, and 2 times 1 is 2. Okay, so our solutions here to this polynomial are 1, the one they gave us, and then also negative 5 plus the square root of 5 over 2, and negative 5 minus the square root of 5 over 2. Okay, so what the factor theorem allows us to do is take when we know one of our factors, use synthetic division to break it to something of a smaller degree so that we can actually find the zeros. Because if we come from where we started, we would just be out of luck. We'd just have to guess and check. So that brings us to this part of your assignment, which asks you to match each polynomial to its zeros. Okay, so when we're matching polynomials to zeros, you have several options. There's lots of ways you could do this. My suggestion would be to try to find them if you can, and if not, then use the factor theorem to break your problem down. Okay, looking at this one, again, zeros are when you set it equal to 0, can you solve it? Okay, this one we actually can. We can factor that. We can take an x out of both of those, and we're left with x squared minus 2. Not 12, but 2. Okay, we can set each of those factors equal to 0 and solve them. So I get x equals 0 is one of them. The other, I would add 2 to both sides. This is going to be kind of messy. And then to get rid of the squared, we take the square root of both sides, and you have to put plus or minus in front. So I also get plus or minus the square root of 2. So the zeros for this one are 0, positive root 2, and negative root 2, which it looks like is C. Okay, I'm going to erase this, so if you need to pause to write things down, go ahead and do that. Okay, so the answer to this one was C. We found that one because we could actually factor it. This next problem, we cannot factor that. The only hope would be grouping, and grouping doesn't work. So we're going to have to kind of check with some of these others. We can probably guess it's not going to be this one again. Okay, I'm guessing it's not that one. No, it's not that one. So what we're going to do instead is look at the other answers. Well, that looks really ugly to me, with 3 minus the square root of 41, so I'm not going to try that one yet. I'm going to try this one down here. Let's see if 1 is a 0 for this polynomial or not. And remember, the way we check that is we do synthetic division with the number and our polynomial. If we get 0 as our remainder, it is a 0. If we don't, it's not. So let's try that. We bring the first one straight down and we multiply. And we multiply and add. And we multiply and get negative 20. 1 is not a 0 for this particular polynomial, so I know D cannot be the correct answer. Okay? Once again, B was pretty darn ugly. I'm not ready to go there yet, so I'm going to go ahead and try A. Okay? Once again, I'm going to go ahead and erase so that I have room to start over. The first one was C. Let's try this next one. Let's try negative 4. Let's try these options up here. Okay, so I use my synthetic division to check negative 4. My coefficients are 1, 2, negative 11, and negative 12. Bring the first number straight down and start. We multiply and we add. We multiply and we add. We multiply, and look at that, the remainder is 0, so we know negative 4 is one of the zeros, okay? which means that's probably our answer. How could we find the other two if we wanted? We write this, we drop it 1 degree, so we have 1x squared minus 2x minus 3, and set that equal to 0. It factors as x minus 3 times x plus 1, and gives us the answers 3 and negative 1. So A is indeed the correct answer for 2. Okay, let's erase once again. This last one down here, notice we had a squared, which means we can solve that to find the zeros. Anytime you have squared, you can either factor it if it factors or use the quadratic formula. This does not factor, so again we're forced to use the quadratic formula. B plus or minus the square root of b squared minus 4 times A times B. Okay, let's simplify that. You want to simplify carefully. We get 3 plus, without a highlighter, we get 3 plus or minus the square root of, this gives us 9 plus 32, which is 41, all over 2. So that gives me 2 zeros, 3 plus the square root of 41 over 2, and 3 minus the square root of 41 over 2. Okay, so that helps me to find my zeros. Okay, the last thing they're going to ask you to do is put everything together. Okay, and they will give you an example of a problem, and they will say, here are the zeros I want you to have